Hi, I am Mali, and welcome to the channel. In the previous Flux tutorial, we built a comprehensive LLM workflow for Flux. During Upscale, we encountered some issues that are pretty common in diffusion models. We fixed this to give realistic textures on human skin by creating a custom node called Noise plus Blend. The upscaling process in diffusion oversmooths the textures and makes the skin look plastic, with fine, smooth velvet lines. By injecting Gaussian noise into a mask area in between the diffusion steps, we can maintain the original skin texture. Using LoRa's and low guidance, we can get good skin and textures for the original generation. Notice the eyebrows, hairs, and the area around the cheek, nose, and lips. This technique will also work for landscapes or any other textures. Complete control over the noise and blending allows you to fine-tune and preserve details in the diffusion upscale process. The InstantX team and Shaker Labs released the ControlNet ProUnion model for Flux. Using our ControlNet Union Pro node, you can creatively use the different ControlNet types. Some creative use cases include taking pixelated game assets and upscaling in high resolution. And while maintaining consistency, recoloring it. Restoring old photos works as well. When it comes to maintaining the old photo consistency, it's on par with third-party apps like Topaz AI and performs better than Super. You can use the ControlNet Union types to unblur images. These are actual DSLR photos blurred in Photoshop to test the concept. Let me show you how to integrate these upgrades into the previous Flux workflow, and my hacks for reliably achieving these results. A big shout out to all the paid channel members. Your monthly support keeps the channel going. This tutorial is a continuation of the previous Flux video. If you haven't watched part 1, the link for that video will be in the description. In the last video, Seth did not have time to summarize the workflow, so let's start by outlining the existing workflow built so far. By default, image-to-image and in painting are disabled. Due to the T5XXL clip, the workflow uses LLMs for prompting. This is the main switch that allows you to select an LLM input. When using an image reference, you basically choose option 1. The LLM instructions are designed to make a comprehensive prompt and summary for the clip L. Text LLM allows you to put in a custom short prompt that gets expanded to 512 tokens and generates a summary as well. If you don't want to use any LLM, just disable it and put in your own main prompt and summary. We used Ollama for the LLM because it is modular and open source. You can choose the model that would work on your system. For the vision model, you can select the Lava 5 billion model or go higher up to 34 billion parameters, depending on your VRAM. You also have the option to offload the local LLM and switch to an API interface. All you have to do is replace the Ollama nodes. Ensure that the connections are maintained. Use the exact system instructions for the API LLM nodes. We personally use Gemini Pro as it's highly accurate for the image descriptions. So, with the workflow, you can generate an image using a reference image. Put in any image as a reference, select Image LLM, and you get an output. You have the option to use the reference image ratio or put in your own ratio and resolution. You can use the second switch to modify the prompt generated from the vision model. While using a reference image, you can enable image-to-image. This will switch the latent from empty to the reference image. When doing image-to-image, you can get a similar output or use the modify switch again to change the image-to-image output via prompting. These have been showcased in the previous video. You can also do image-to-image and disable LLM to control the prompting completely. Use the max shift variation options and get creative control over the output. These techniques can achieve style transfer and change the image style, elements, background, or subject. Now, you can also not use any image reference and put in whatever text you want. The LLM will elaborate on the keywords you put in. Just remember that the final prompt will be as good as the LLM model used. The Flux core group is where you get the basic first generation. Here, you can set the LoRa's, guidance, and sampler settings. This group is called the 1x detail group. The objective here is to 4x upscale with details and then do an image-to-image with low denoise using the Flux sampler. We then downscale the image by 4x. We repeat the process using another upscale model but retain a 1.26x approximate upscale this time. The image is then passed on for a 2.5x upscale. This is using SDXL and Ultimate SD. We don't use Flux here due to scanline issues and poor performance. After that, use an upscale model with a 4x upscale and a downscale by 2x to get a 5x upscale image. This group then takes that image and post-processes, if any, to give you the final output. Now, this part here is for inpainting. When enabled in settings, you can inpaint the Flux core output and then pass on the inpaint output to the 1x details and the upscale process. Because the upscale oversmooths the skin and low detail textures, especially in landscapes, over here, we will add the noise plus blend node and the masking required for it. So, for that, we need to auto-switch the upscale models from the 1x details, then inject the noise and blend before passing it on to the 1.26x upscale. It then has to bypass the Ultimate SD upscale since that's pixel to pixel and will directly go to the 5x upscale. Somewhere here, we will add the entire ControlNet union and create logical processing to turn it on or off. Those changes will go into the Flux core group only. I will do this step by step and explain along the way, but first, let's look at the new requirements. I am only going to mention the new node and model requirements. Firstly, you should update ComfyUI. I am using the portable nightly version. Besides the previous requirements, the only new custom nodes are the face restore nodes. A disclaimer, this node is not updated, and only the CodeFormer model works. GF Peak On doesn't work anymore. This node is used for face restoration. So, if you will not use face restore on old or unblurred photos, this custom node is unnecessary. The second node you need is the ControlNet Auxiliary Preprocessor node. This is required for the ControlNet Union Pro. Lastly, update the ControlAltAI node. In fact, ensure all custom nodes are updated. We currently use 2 models for the upscale. However, for the preserve details function, we alternate between different models. When using preserve details, you have the option to switch to a model designed explicitly for landscapes and textures, that is, non-human faces. The 4x Nomos 2 is for landscapes and is used at the last stage. Lexica.2 is used for the default workflow and excels in adding details to AI-generated images. For the default workflow, we alternative between Lexica and FaceUp models. FaceUp is used for a softer upscale. Switching between these helps to balance out the sharpness in the bokeh. For the preserved details on the skin, we alternative between FFHQ and FaceUp models. To restore the face, you need to download the latest CodeFormer model. The downloaded models should be placed in your Comfy Models folder. After you install the Face Restore custom node, the CodeFormer model will go into this folder. All the 4 Upscaler models go in the Upscale model folder. The ControlAltAI Flux ControlNet node is designed and compatible with the InstantX Union Pro model only. Download the Diffusion PyTorch model safe tensor file. In the Models, ControlNet folder, create a new folder called Flux and put the downloaded file here. Rename the file to a recognizable name like shaker_flux_union_pro. Let's make some minor changes before proceeding to the main node integrations. In Settings, delete these nodes and rename the note to just Settings. We made an integer settings node with a simple enable/disable button. This node is designed to give you only 2 outputs. When disabled, it will output an integer value of 1 and, when enabled, an integer value of 2. This helps with any manual switch with 2 options. We may later upgrade the node to support switches with more than 2 options. But for the current workflow, this will do. Connect this with the image-to-image Git node. And do the same for the in-paint settings. Duplicate this twice. One will be for the preserve details logic, and the other for the landscape logic. The workflow will be designed so that when you enable preserve details, it will switch to a different upscale model from the 1x details group and apply noise plus blend to the whole or only a mask region. For the landscape, we will add the logic only at the 5x upscale stage. So when you want to use the landscape upscale model, you must enable both preserve details and preserve details landscape. In the input image group, add display integer nodes and rename them to width and height. When using unblur or recolor ControlNet, we need this to verify that the actual resize resolution matches the Flux resolution calculator. I will explain why when we get to that part. If you don't have a string output added to the resolution calculator, then connect with a showText node and rename it to resolution. As mentioned earlier, you can change the LLM model for better performance. For the tutorial, I will switch the vision model to the Llama 34B model. The 34 billion parameter model is 20 GB and will just work with the 4090. There is an 8 GB model with 13 billion parameters. Use that if you have 12 GB VRAM. These higher vision models better describe the input image than the 7 billion parameter model. In case you don't want the LLM to process locally, just remove Ollama and add any custom node that supports your LLM via API. For the image modify and summary LLM, change the model to the Llama 3.18b Instruct FP16. Do the same for the text LLMs as well. The Instruct model understands system instructions better without errors than the normal 8B models. This model is around 16 GB and will require a higher VRAM GPU. There are quantized versions of the model as well for lower VRAM. Let's first understand how injecting and blending noise works. The node has 2 options, a noise scale and a blend opacity. The noise scale determines the amount of Gaussian noise it will generate. The blend opacity refers to the transparency of the noise when blended with the original image. The node uses the soft light blend mode to blend in the noise. Soft light is a contrast blend mode that applies either a darkening or lightening effect depending on the luminance values of the blend layer, but more subtly than other contrast modes like overlay or hard light. The noise scale is sensitive. The recommended values are 0.3 to 0.5. You should adjust this depending on how smooth the image comes out after the 1x details upscaling. Ultimately, there should be a balance. The noise we add here should be denoised via a K-sampler, but not entirely. The blended image output will add noise. Here, the noise is applied to the entire image. Let me increase the noise for better visibility. When dealing with portraits, you want to apply the noise only to the skin and ensure the background has a smooth bokeh. When a mask is not connected, the node applies noise to the entire image, and when you connect it with a mask, it will apply the noise only to the masked area. Wherever the noise is applied, the next stage of Upscale will preserve those details. Let's integrate this into the workflow and automate it. The preserve logic is going to be a bit different. We will get two logics, one which determines if the setting is enabled or disabled. The other will enable or disable a dummy node, based on which we will enable or disable the 2.6x Ultimate SD Upscale. The second logic will be linked with the first logic, that is, if preserve details is on, we will disable the Ultimate SD Upscale and vice versa. Add a logic compare node along with the impact integer and set the value to 2. Also, add a get node and get the settings for the preserve details. We will get a positive boolean when the settings are enabled, since the integers will match. Otherwise, the boolean output should be false. After adding the control bridge node, convert the mode to input. Connect the mode with the logic boolean and change the behavior to mute. The impact integer will connect with the control bridge value input. Add a set node for the boolean logic and name it preserve details logic. Now we will add a dummy node. By dummy, I mean the only function of this node is to have an enabled or disabled status. And based on that, we will enable or disable another node. The convert data type node from the impact pack is perfect for this function. Connect it with the control bridge. Then use the set node to set the boolean output as the preserve details status. Organize these nodes into a group named preserve detail logic. Okay, so let's test this. Disabling the preserve setting should also disable the dummy node. If you add a display any integer, the response should be false. The logic is working. Let's proceed. For the noise plus blend group, add 3 get nodes. Add an RG3 switch any node. Get the 1x detail and image to image and connect as shown. This further connects to a bridge control. The bridge control always needs some input, otherwise, errors pop up. So, if you disable 1x details and run the workflow, everything will go smoothly. Rename the bridge control to noise blend control, convert the mode to input, and change the behavior to mute. We will use the if none logic node from the impact pack. This node will accept an active or null command and can pass as true or false boolean. When the preserve logic status created earlier is muted, this node will receive null. That means the bool output will be false, and when that is false, the noise blend control will mute the connecting node. Connect the preview nodes and rename them for organization. We need to pass on this output to the 1.26x upscale, so connect a set node with the blended image output. Create a group called preserve details noise plus blend. Now let's test. With the settings off, the node should turn off. The logic is working. Let's turn on the preserve details settings. Note that all Flux Core and 1x details groups are disabled. We should not get any error from the noise blend control bridge. For the Preserve Details mask, copy the SAM2 masking nodes from the InPaint group as shown. You want to put face or person here, depending on your use case. Connect the SAM2 segmentation with the Gaussian blur mask. For manual mask manipulation, use the Pixelwise Mask Plus mask and connect it with the Grow mask and the Preview bridge. You can add to the SAM2 mask by manually masking on the Preview bridge. Adding an invert mask node and switch would be the easiest way to get an inverted mask when needed. Add the Cache Purge node here to clear any SAM or Florence models that have been loaded. Set this output to Noise Mask. Organize the nodes to a group called Preserve Details Mask. By default, the Get node should be set to 1x details. Connect the Noise Mask output for the Noise plus Blend. We will later add the Preserve Details mask group to the Global Groups node. When not in use, you should disable it. Let's test this. Also, keep the Grow mask at 0 unless intended, as you want the noise to be applied accurately. Changing the input to image will allow me to use the load image directly for the test. That works, and let's move on to make changes to the Upscale nodes. The Preserve Details settings will use a different combination of Upscale models. I have selected models specifically trained for realistic portraits. Add the Choose Upscale Model node. This node is designed to switch between two upscale models based on true or false Boolean logic. By default it's set to true, which means it will use Model 1. To use Model 2, the Boolean response should be set to false. We will use the Preserve Details logic to automate the Boolean response. Convert the use Model 1 Boolean to input. Choose the 4x face-up DAT model for the Preserve Details. Ensure to connect with the Upscale image node. Get the Preserve Details logic and connect it with the Choose Upscale Boolean. Let's test this with the Display Any node from RG3. The error is because only the sampler is muted. Let me mute everything else in the group. You can verify which model is selected by the object number. In this case, the number ending with 180, which is the second model. Let's turn on the Preserve Details settings and recheck. So the logic is correctly working, and the first model is selected. Let's move on to edit the 1.26x upscaling group. Make some room in this group, as we also need to add logic for the image input. Copy the upscale nodes from the 1x details group. Change the second upscale model to 4x face-up DAT, and the first one to FFHQ DAT. We must ensure that noise plus blend output is passed on when preserve details are on. Otherwise, the 1x details output should be the input. The preserve details image is the same as we set earlier as the noise plus blend output. Use the settings preserve details for the switch selection. Now, let's move on to the 2.56x upscale group. Expand that group as well to add the logic. We will use the preserve details status to enable or disable the ultimate SD upscale node. Add a control bridge node. Connect the positive clip via the bridge with the ultimate SD. Convert the mode to input and set the behavior to mute. Get the preserve logic status and connect it with the if none logic node. The original logic was that if the preserve details settings are on, then the dummy node is enabled. When that happens, we want to bypass the ultimate SD upscale, so we will just disable it. Hence here, add the Boolean reverse node and make the connection. Now enable this entire group, turn on preserve details, and test the logic. Logic is working, let's try it one more time. Perfect. Let's disable the group and setting and move on to the last upscale group. In this group, we have to add multiple logics. It's a bit tricky. In testing, I discovered that using the same upscaler at this stage does not work for anything other than human skin. So we must first ensure a logic to know if preserve details is on or off and then proceed accordingly. We then have to include a sublogic to check if the landscape setting is on or not, and if it is, we use a different upscale model best suited for landscape and other textures. We also should ensure that the image logic is applied here, that is, if the preserve logic is enabled, it takes the 1.26 output. If not, then the output from the SD upscale. Lastly, we must control the downscaling accordingly via logic so that the output remains at 5x, regardless of the preserve details settings. The Upscale Model 2 is to be used when the Preserve Details is on, otherwise we will use the Upscale Model 1. Like before, add the Preserve logic details. We will use a standard switch, and the landscape setting to switch to the landscape upscale model. For the landscape, use the No-Mos 2 model. Get the landscape settings and connect it with the switch. First, let's test the logic. Add the display any nodes to all upscale outputs. Only enable the upscale nodes for the test. As per the logic, since preserve details are off, 9A00 should be the output. Now CC80 should be the upscale model. Note that when turning on Preserve Details for landscape, always ensure that Preserve Details is also on. That's how the workflow is designed. And the logic is working correctly for the landscape as well. Connect the switch with the upscale using model node. Then duplicate the get node. Add the RG3 switch any. This is a simple logic. If the 2.52 output is available, it will use that, otherwise it will use the 1.26 output. Whenever the set node is connected to a muted or bypass node, it registers as null. That's why any node switch here will work. Depending on the input image size, that is, if it comes from 2.52x upscale or 1.26x upscale, we will control the upscale image by node. Note that this node is set at 0.5x, which is in downscale mode. If the image input is from 1.26x upscale output, then we must bypass this node to avoid downscaling. Add a control bridge, convert the mode to input and change behavior to mute. Like before, we will use the if none logic node. Get the preserve status detail and make the connection. Connect the upscale image output with the signal input and pass it on to the upscale control node. For the final set output, we will use the switch any logic again. The downscale node will connect first, then the signal out from the if none node. Rename the impact if none node to status logic. I forgot to mention that like the ultimate SD upscale, this node should be muted when the preserve details setting is on. For that, we have to add a reverse boolean here as well. To test this logic, I am not going to run the whole workflow, add a load image and connect it to first any switch input. Now directly connect the any switch to the status logic. Let's test with the preserve details settings on and off. With the settings off, it's working correctly. And it works with settings on as well. Revert the testing changes, and let's proceed. I generated this image using Flux Core. Everything else is disabled. I used low guidance and 2 LoRa's. First, turn on preserve details. If you are doing this for a landscape or any other texture, turn on preserve details landscape as well. After we finish the entire workflow, we should add the preserve details mask group to the Flux group's control node. For now, I will do it manually. Generate the 1x add details output. Let's zoom into the 1x details output. You can see that the SAM2 mask did not include the glasses or the head. I will just mask it manually to cover the entire face and head area. Some areas are missing, let me redo the masking. Okay, perfect, let's proceed with the noise injection. The basic concept here is that wherever you add noise, that has to be denoised via a K-sampler. So, say I increase the noise scale to 1. You can see that too much noise was added. At the next stage, the K-sampler default is usually 0.2. But this won't be enough, and increasing the denoise always doesn't work. There is a limit to how much noise you can inject. Put just enough noise that details don't change when using K-sampling. If you use a higher denoise value, then details may change, or unnecessary details may be added. Unless adding more details via K-sampling is intended. After some testing, I came up with these values. Typically, I would recommend a general setting of 0.3 to 0.5 for the noise scale. Since we ourselves have developed these nodes, it is easier to come up with these values and to properly test them. For the blend opacity, around 10 to 25%. There are cases where I have gone beyond these. For example, with a specific custom LoRa, I used higher values, and that worked for that specific case. What I am trying to say is consider these values as a starting point and then increment or decrement them as per your own use case. This is a result of injecting too much noise. You may not see these artifacts immediately in the next stage, but they start appearing slowly at each stage. The final result will look like this. Let's change the blend opacity to 80% and see how the results appear in the next stage. At this stage, it looks this way. Forwarding this through an upscaler gives those weird artifacts. Let's change it back to 20% and proceed. The low noise injection is much better here. Enable all groups except in painting, and let's compare noise injection and blending with and without it. Loading the image I generated with the same settings without noise and blend node for comparison. You can clearly see the difference. The left side is without noise, and the right side is with noise plus blend. This will keep the skin textures as realistic as the original generation. If the Flux Core generation is not realistic, this won't make it realistic. It's only supposed to preserve details. We recommend using LoRa's, which give realistic skin with Flux and a low guidance like 2 to 2.5. This will also work for landscapes or any other texture. Different noise and blend values are to be used for landscapes, and it works very well. Although technically tested on Flux, this technique should work with SDXL as well. If any of you tested on SDXL, let me know in the comments if it works well or not. This would be the setting for the first ControlNet. Duplicate and adjust as shown. For the second ControlNet, we will use a basic Boolean logic. Connect it with a set node. Add the face restore with model node. Connect the model loader and choose CodeFormer. GFP Gone does not work and is broken after the Comfy update. CodeFormer works perfectly. Get the image to image output and connect. Then, add the color match node. Add the nodes to a group called Restore. The Restore group should always be off unless you need it. For the ControlNet image input, we set it up so that when Restore is on, it will take that input, otherwise, it will take the direct image to image input. The ControlNet Union supports 7 ControlNet types. I will add all the preprocessors and connect them with 2 switches. The first one would be Canny Edge. For the second one, use the Tile preprocessor. For low quality and blur, we use the direct image input. This is only when the input is actually low quality or blurry. Then you can use DW pose or open pose for the pose type. For depth, I recommend using Depth Anything version 2 relative. Ensure the large model is selected. Lastly, for gray, use the Desaturate node from Comfy Essentials. This node basically converts the image to black and white, which we can then use to recolor. Let's run the preprocessors and test. Add a switch and connect each preprocessor output in the order shown. Rename for organization and easy selection. For low quality and blur, connect the input image directly. Now duplicate the switch with the connections. Add the Flux ControlNet Apply. This node is designed to work only with the InstantX Union Pro model. Get the Flux guidance. This is the conditioning set in the Flux core. Connect the first switch output with the image input. ControlNet for Flux requires VAE, use the Get node and connect. I will show you how to use two control nets in some examples. At this stage, I do not recommend using more than two control nets with Flux. We will add the second control net to a logical setting, the Boolean that we set earlier. For some things, you require two control nets as they are simply not possible with a single one. The second control net, by default, will be bypassed unless turned on from settings. Add a control bridge and rename it. Then convert the mode to input. Connect the second switch with the control bridge and set the behavior to bypass. Get the control net 2 and connect it with the Boolean mode input. Now let's test. When the setting is off, it should bypass. Add a switch any node. Connect the second control net with the first input and the first control net with the second. This is required because we are using a set node to set the control net conditioning. The set and get nodes do not work when connected to a muted or bypass node. If the connection was direct, then switch any node would not be required here. Organize and name the group Union ControlNet Core. We will now add the ControlNet logical flow to the Flux core group. Get the ControlNet conditioning and add a switch. Connect the default Flux conditioning to input 1 and the ControlNet conditioning to input 2. Convert the selection to input and connect the settings ControlNet logic to it. Connect the switch with the Flux sampler. Here, I found it best to use only the conditioning for the Flux core. For further pipeline stages, we use normal conditioning and bypass the ControlNet conditioning. However, you can use the ControlNet conditioning on all stages of Upscale for experimentation. Set the switch conditioning, in case you want to automatically use the appropriate conditioning when the ControlNet is enabled. I would be showing the ControlNet examples without any custom LoRa's. Add an any switch and reconnect as shown. Before proceeding, add the new groups to the Flux Groups control as shown. You can copy this node and paste it wherever necessary for easy access. We also need to make some changes in the post-processing. When using the blur ControlNet to unblur images, there might be some color loss compared to the original. I will add a switch here and set the color match to bypass. Not going to add setting logic for it because this is used only for specific cases. By default, color match won't be used unless you enable and manually change the switch. And that is it. Let's proceed with understanding the intricacies of the Flux ControlNet union. You should know some basic things about ControlNet. This is very different from SDXL, so the same concepts, values, and settings don't apply here. You have to select the ControlNet union type. They all have different use cases and work differently. Always ensure that you select the proper ControlNet image preprocessor matching the type. In some cases, you can use one preprocessor for another type. For example, the tile preprocessor can be used for tile or also for blur. The strength and end percentage both have a drastic impact. By default, start with 0.4 strength and end percentage at 50%. I will demonstrate some use cases and how manipulating these can help you achieve the desired output. The first example is taking this pixelated image and making it into a 3D version. Turn on the settings and disable Flux Core. I have enabled the custom ratio here. So, the ratio from the input image will be used. For this specific image, I just used the text LLM. I put this in, and the LLM gave me these elaborate prompts. I will paste the prompts here for demonstration. For the sake of consistency, I am using the already generated LLM prompt. So, disabling LLM and proceeding. The union type will be low quality as the input image is low quality. First, let's try with the default values and use only one ControlNet. This way you can understand how the values affect the generation. The preprocessor selection is low quality, which is a direct input image. Let's set the default end steps at 50%. Since we want to convert this to 3D, we want to give the AI more room to hallucinate. You can control that with the end percentage rather than strength. The higher the end percentage, the more consistent it will be with the input image. For the strength value, I would normally recommend values between 0.2 and 0.65 or 0.7 in some cases. You will understand better as I progress through the different examples. So you can see it's too much hallucination, and this is similar, but it doesn't look like any ControlNet was used. As per the SDXL concept, say we increase the values, strength to 0.6, and end percentage to 1. This is very extreme for Flux. You see, Flux already has a very good image-to-image ControlNet without the ControlNet. This was demonstrated in part 1 of the video. But first let's see how these results are. And this is just like the input image. It's like a pass-through. That's what happens with Flux ControlNet. Now let's try something different. I am reducing the strength to 0.4, which is the default, and the end percentage to 0.2. We will enable the second ControlNet for the pose. But I won't use DW pose here, instead, I will use depth. For depth, we use a lower than default strength of 0.3 and the same end steps. And why are we using depth for pose? 'Cause the image is so pixelated, DW pose cannot understand anything and gives out a blank output. But you can see the depth will accurately give the correct pose. You can see that using lower strengths, end steps, and combining two ControlNets works, and it adheres to my prompt. Let's try this with another image, a low-quality Honda portrait. This is, however, not pixelated but low quality. And assuming we want the same thing, a 3D portrait of Honda. So, this is the text prompt and the LLM output. Here I will disable the second ControlNet. The ControlNet type will be the same, but let's increase the strength and end percentage slightly. And that worked perfectly. Let's move on. For the next example, let's try something out of the box. This Mega Man image is again very pixelated and low resolution. Assuming the same desired output of getting a higher quality 3D version of this. Instead of a direct image input, let's use the tile preprocessor, which blurs the image. But keep everything the same. And how cool was that? Let's see what happens using the direct image input instead of the tile preprocessor. Okay, so why did this happen? For one, the ControlNet was at 50% end steps. Now, with tile also, it was at 50%, but there is a difference. The image input here was blurry. Because of that, it adhered more to the prompt, and the AI had enough room to hallucinate. The tile image also acted as a pose. The direct pixelated and low-resolution input did work. But not with the goal of getting a 3D output. It worked in the sense that it took a low-resolution pixelated image and upscaled it. Maybe increasing the end percentage here would have acted as a better pixelated upscale. These examples were kind of the basic nuances of Flux and ControlNet. Let's get into something more complicated. Let's take the previous output of Mega Man and recolor it. Let's do this live with the image LLM without using any saved prompt. For the modified prompt, we'll put in make the character colors psychedelic. And by the way, Ollama Vision Node had an update. We can now use a fixed seed. Change the preprocessor image to gray. Let's choose the strength to 0.5. Or maybe 0.4. But here the end percentage is very important. Since we are changing the color, we want to maintain consistency. So the end percent here would be 0.9. It would use the black and white image 90% of the steps and use the last 10% for recoloring. So we took the colored image and desaturated it. Now using ControlNet, we will try and reapply our own colors. You can try end steps at 0.95% to make it more consistent. But the fact that you can do all this opens up a lot of creative opportunities. Let's explore how to use ControlNet Tile for upscaling. This is 191 by 191 pixels. And using tiled ControlNet and the current workflow, we will get a 5K output. Change the preprocessor image and union type to tile. Keep the strength at 0.65 and the end percent at 0.9. And I am doing a full run for this example. We don't need preserve details. So those groups and settings are off. Let's change the comparison to the input image. And there you go, a 191 resolution to a 5K upscale. For tile, a strength of 0.65 approximately works. If you want to add some more details during upscale, reduce the end percent to 0.75. Then the AI gets creative in the upscale. So you can get a consistent or creative upscale as per your use case. Also, remember that this workflow maintains consistency during upscale, so when I say adding details, it would be at the Flux core group stage. Whatever you get at the Flux core group stage, everything is maintained throughout the upscale process. So, changing the tile end percentage would affect the raw output, which would then be maintained during all upscale stages. Now let's move on to something even more difficult. Unblurring non-AI images. This is an actual DSLR photograph and I overblurred it on purpose. The first thing to do is disable all groups. Since this is a non-AI generated image, we need to ensure that the input and output resolutions are the same. The height doesn't match. Change the method to crop. Letting this queue run as we also need to check the LLM. Sometimes, the LLM won't recognize it as a photograph and may mistake it for a digital painting. If that happens, you have to modify the prompt. Let's run it again with the fill, crop method and see if the resolution is an exact match. Whenever you restore a photograph or unblur it, specifically when it is not AI generated, use the fill crop so the input resize and the output size calculation match. For human portraits, I would use a different method of unblur. But for non-human subjects or objects, use the direct input as a preprocessor and the blur union type. The strength would be around 0.4, however, the n% is a bit tricky. If you do it too high, then the image will still be blurry, and if you do it too low, it will look very different. In this example, I don't want an exact original, but something similar. So I will go with 0.7%, which should do the work. First, we need to check the image in the Flux core as we can maintain consistency for the upscale. For real-life images, use low guidance. Okay, so this is not exactly the same, but good enough for what I was going for. Let's do a comparison. You can clearly see the color difference. I am not too bothered by this image for consistency. In the following example, I will show you how to maintain maximum consistency. But let me show you some techniques for upscaling this. I will turn on Preserve Details and Details Landscape. Use the landscape for a non-human subject or object. I won't be turning on Preserve Details Mask, as I want to apply noise to the entire image. I want it a bit noisy that it looks like a photo. This is fine, let's check out noise and blend. This noise level is acceptable to me, you can adjust it as per the use case. The thing I like the most is that this maintains focus on the head while keeping everything else out of focus. The actual photo was exactly like that. Play around with the end percentage, it's quite sensitive. The coloring is off though. Let's fix it in the post-processing group. Enable the color match and select it from the switch. This is much better. Let's move on to unblurring a real person while trying to maintain maximum consistency. This is a blurry photo of Seth. The goal here is to maintain maximum consistency, which would be on par with photo restore applications from Topaz AI. There would be differences, but in the end, if the photo is of Seth, it should look like Seth. Codeformer is needed to restore the face. Turn on the Restore group. Lower the fidelity, the less it looks like the actual person. In this case, I will increase it to max. The first ControlNet will use the direct preprocessor. And the second one will use tile. We won't use blur here since the face restore unblurred it. However, it is still low quality. We want it to be 5K resolution. Increase strength and end %. For the second ControlNet, use tile. The tile is blurring everything again. We are using it only for consistency. It helps when we use it at a very low value, say 0.15 strength with an end % of 0.1. This is how blurry the tile preprocessor makes it. Again, change to fill crop to match resolutions and enable both control nets in settings. Ensure that the LLM got it as a photograph. Turn on the Flux Core, Preserve Details mask, and enable Preserve Details in settings. Reduce the denoise to 0.95 and run the Flux Core group. So far, it has maintained consistency. Now, we have to ensure that consistency is maintained as much as possible during upscale. We are really pushing the model here. In the Add Details group, it changes the face at 0.2 denoise. It maintains it at 0.1. So, let's keep it at that. So far so good. Now manually mask the face for the blend plus noise. This noise is a bit too much. We'll reduce it to a very low value. Let's try the entire run now. Okay, I think I made a mistake since the face has changed slightly. I forgot at the 1.26x group we need to reduce the denoise as well. Let's do that and try again. This is the maximum consistency I could maintain without Laura using a real photo. I have tried this with different photos. Depending on the blur level, the settings have to be adjusted slightly. For the Flux Core, don't go below 0.95 denoise, probably max 0.9. For the two upscale stages, if you reduce noise further, you can go even 0.05 denoise. The color is off again. Use the color match to match the color. The glasses details have slightly altered. However, except for the smile and the hair, nothing has changed much. You can never get these results in something like Super, especially when the photo is blurred. For social media sharing, the quality is good enough. Let's move on to some even more challenging to do. Restoring old photos and recoloring them. For this next example, let's take this low-resolution, noisy, blurred, black and white photo. For this one, we used the same settings as the previous Seth example. However, you should ensure that the LLM gets this as a black and white photo. If not, you should modify the LLM prompt. You first want to get a proper black and white photo, then recolor it. The LLM often recognizes it as black and white, depending on whether it can understand the image. You face these issues mostly with low-quality images. I have checked the Face Restore with Topaz AI and some other paid face restore tools, and it's exactly the same face that you get. So, no paid solution is better than what we are getting with this workflow. In both upscale stages, we keep the denoise value at 0.2 only. This is unlike the previous example, where we had to reduce it since it was changing the face. We will use the default noise plus blend values and add noise only to the face. This way, during the next stage, it will uniformly denoise the entire image. As you can see, the noise is uniform. Remember that the level of noise or smoothness is basically in your control, it's just a matter of settings. You can clearly see the restoration's face likeness. We will now take this final image and color it. Here select the final 5K output image. We only need one ControlNet to add color. Select the gray preprocessor. You can also use the direct image input, as it's already black and white. We will use Modify LLM function to give this image a natural color. You can be specific, like vintage coloring, 1970s coloring, etc. The LLM recognized it correctly as a black and white image. A simple make it a natural color photograph prompt. When adding color to a black and white photo, the sampler and scheduler give different results. Some will give you blotches, and some will look like sepia tinted. Let's try Euler with normal first. This is okay, but for black and white photos DDIM and DDIM uniform perform the best. Also, 20 steps would be just fine. Remember to keep these same settings for 1x details and the 1.26x upscale. During the upscale, ensure that the denoise is lower, like 0.10 or 0.05, and noise plus blend is on for the face. Take another example. Here, the image is just poor quality. But the details are quite clear and visible. To restore such image, a different approach has to be taken. Here, we use equal values for low quality and tile type, both at strength 0.45 and end % 0.5. The low quality preserves the details, while the tile smooths them out. So, if you want more noise, increase the low quality values, and if you want more smooth, increase the tile values. Restore is also recommended to be used here. Again, we can see when the image is detailed, the LLM can recognize it better and does not require prompt modification. The face restoration from CodeFormer is less prominent here, which is obvious. In the end, whether to use it or not depends on the input image. Let's do a quick comparison before moving on. I would like to show you one last example of using ControlNet to recolor architectural images. When it comes to architecture, my testing shows that using gray and depth both helps. Gray for recoloring and depth for the prominent objects. Define the coloring theme in the modify prompt. Keep gray at 50% steps and depth at 20% steps. Also, keep the depth strength at a lower value than gray. Increase the guidance to 3.5 or 4. When we don't use depth here, it hallucinates some objects as per the theme prompt. Some changes are obvious, but it will maintain the overall structure and architectural setting. Let's randomly try another theme. So the LLM gave it a black, silver, and neon green theme. If you want, you can be very specific here as well. There you go. GPT-generated unified format, or GGUF models in ComfyUI are designed to support quantized model files, allowing you to run Flux on lower-end hardware with limited VRAM. GGUF models use mixed quantization, meaning different layers in the model are quantized to different bit precision levels. This allows for significant memory savings without drastically sacrificing quality. Using GGUF allows you to use Flux on low as 6 GB up to 16 GB VRAM. Basically, install the custom node from the manager. It's a straightforward install. I am on the latest version of Comfy, and it's advisable to have all custom nodes updated. The workflow integration is very simple. You need to add the GGUF Net loader and the GGUF dual clip loader. That's all. For the models, as per my testing, don't go below the Q5_1 version. If your system cannot run this model, then it's not worth it. SDXL will give you better results and image quality. For the T5XXL clip loader, the Q5_K_M model is seriously the bare minimum. Not recommended to go lower than this. If you go to the GitHub page right at the bottom, you can see the model's link. I will leave it in the description. I won't go into explaining the technicality of these terms due to time constraints, but I will explain what you should look at. Concentrate here. The higher the bit, the more VRAM it needs. The size of the model will give you an idea of approximately how much VRAM it will take. Anything below 5 bits gives horrible results. 6 bits is not worth it in terms of requirements and output. And if you are going to use the 8-bit one, just use the normal model in 8-bit weights. 5-bit is the best sweet spot according to me. The same concept for the T5XXL clip model. For this, I just followed the official recommendation. I have not done any testing on my end. The clip goes in the model's clip folder. Create a separate GGUF folder for better organization. The main models go in the UNet folder. Okay, so let's compare the models. This is Flux Dev at 16-bit floating point precision. And this is generated using FP8 weights. Now let's see the 5-bit GGUF model. You can see it's pretty on par. Let's compare with lower bit GGUF models. I hope the tutorial helped you better understand Flux and that you learned something new in ComfyUI. It's even easier now to switch to ComfyUI, as it now comes with an executable installation file. And for next time, maybe we will do something with Stable Diffusion 3.5 large. So stay tuned, and until next time.